Hello and welcome to a video from filmsbychris.com. That's Chris with a K. I'm Chris with a K. Today I am starting a series of videos on messages, but we're looking at three things across all these videos, and hopefully they're all going to be short videos. They're going to go together eventually in one video. I'll compile them into one video or a playlist, but we're going to be looking at encryption. We're going to be looking at encoding, and we're going to be looking at hiding messages or steganography. And the end goal of a lot of this is to whatever we do, whether we're encrypting or encoding, eventually get it to a format where it's typable characters. So whether we're sending pictures or binary information of any type, the output is going to be plain text that can be typed so you can send it, for example, through a text message. And it doesn't matter what, medium you're transferring it to. If you can type it, you can send it, even with like Morse code, for example, which we will go over a little bit of that in one of these videos. So let's go ahead and jump right in. We're going to be looking at some OpenSSL today to encrypt some text. There's lots of ways to encrypt text. OpenSSL is a very, very common way. It's a very secure way. But when it comes to encryption, everyone has all their own opinions on what is best. If what I do here, if you have a different opinion on a better way to do it, or maybe just a different way to do it, comment below and I will review that and maybe do a follow-up video. So let's go ahead and jump right in. Okay, here we go. Encrypting messages using OpenSSL. Probably already have it installed on your system. If not, use your package manager on a Debian-based system. You would sudo apt install OpenSSL and then you'll have it installed. First, we need to have a message to encrypt. So we could pass OpenSSL a file if we want to encrypt a whole file. But in this case, I'm just going to encrypt some text that I'm going to type here. I'm going to say echo. This is my hidden message. I type that and it prints my hidden message. At this point, we can pipe it. So the pipe character means take the output of that and pipe it, take it and put it into OpenSSL. What are we going to do here? We're going to -E to encrypt using this encryption format here. We're going to hit enter. It's going to ask for a password. Type a super secret password. I'm going to use password in this example. And type it twice to verify it. And then we hit that. And it did encrypt it. That's what this is right here. It even tells us it's salted. Okay, so salted means that it throws basically some random information in there to prevent basically brute forcing or lookup tables. We're not going to get into that too much. You can pass OpenSSL a salt argument, but it seems to do it by default. But it also says here that we're using depreciated keys. So basically, it's saying to use one of these two things. So let's use that same command we just ran and add this -pbkdf2. So again, look at the output of the command. If it's telling you something like this, it's saying it would be better. We did it, it worked, but it would be better if you add this. We do that, we type in our password, whatever we want it to be, a second time just to confirm. And you can see it encrypted the message right there. Okay? In this particular case, somewhat looks like regular characters. Looks like there might be a little mark underneath that parentheses there. We want to make sure that we only get output that is typable characters. So we're going to add a -A option. What does the -A option do? The -A option says make sure the output is base 64 format, which we're going to talk about base 64 encoding in a future video. But basically just know this, you can pass anything to base 64. It could be any binary file like a JPEG, an image file, a video file, an audio file, a Word document, a PDF, any file, and it will encode it as typable characters, something you could type on a keyboard. So that's what we're saying here is we're saying encrypt this and then take whatever the output would be, which could have binary information in there, and make sure that it is typable characters. We do that, we type in our password, whatever password we want, and this is our base 64 output. This is something I could type. I could send this as a plain text or in an email, and someone can copy that and then decode it, which we'll decode in a moment. But I want to show you one other option that you're not going to use too much, well, you shouldn't use too much at the shell here, but I can just pass it the -pass option, and then we can say pass and give it a password. So this will prevent me from having, it's not going to ask me for a password that I have to type twice. It just says use whatever I type here. Again, I use password, use something better than that, and give me the output. Okay? This is good to know how to do, but you're not going to want to do that at the shell. Why? Because we have a shell history, right? If I go up arrow on my shell, I can go through previous commands, which means anybody can come in and see your previous things. I guess I'm passing it the message this way, so that's not good either. But get the idea that you don't necessarily want your password in your history, right? So you have your password. you might want to use this in a script of some sort where you're going to generate a key and show that to the user, or have them input it into your script that you might use to encrypt multiple things. But you normally don't want to type your password in the command on the shell, right? So we have this output. I also want to show you, if I run that same command multiple times, notice that the output is different. Just look at the last few characters. They're not the same. That shows that it is salting the output. It's even though we're encrypting the same message using the same password every time and the same form of encryption, it is giving us different output each time. Again, to prevent rainbow table lookup tables, things where people have encrypted things like this before and they have just a long list of stuff that they're checking against, okay? It just makes it harder for people to crack your password, right? Or your code, your message. Okay, so we have this message. I can now text this to somebody, email it to someone, type it to someone, send it to somebody in whatever way I want, right? And the only way someone should be able to decode this is if they know my password and also know what type of encryption I use, which we're not going to worry about too much. But I can say now echo, and I can pass it that information. Again, if I do that, it just outputs that information. But again, we're going to pipe it into basically the same thing here. So we can give it all the same information, or mostly the same information. Something we're going to change, though, is where it says E here. For encrypt, we're going to set it to D for decrypt. I'm going to hit enter, and there is our encrypted message now unencrypted. Let's go ahead and do it again with just a different message. I will say, hello world. Boom, I have the output that I can send however I want, email, text, whatever. I could break it up and someone can put it back together, and then I can take that and I can put that into OpenSSL with the same password, and it gets the output that we put in. So that is a very simple, easy, fast way, secure way to encrypt a message. Again, we're passing the text here. You can also give it a file to read and then give you the output that way. That way you're not necessarily typing your message right here on the shell and your password. It's written to a hard drive, then you got to delete, and then if someone gets your hard drive, there's a whole bunch of security things to think about. Doing it on the shell here might be a good idea. If you're working out of RAM, you could work out of RAM only and then delete stuff. Now we're getting into whole other conversations. But this is how you encrypt and decrypt a message, very basically using OpenSSL. Again, people have different opinions on format encryptions. You can look more into any of the programs I'm going to talk about in this series by using the man command, the manual command. So man OpenSSL, it will give you a whole bunch of information on different things you can do, and you can see here that it gives you different options for different types of encryption, right? So you can look more into that and decide what's best for you. Thanks for watching. Visit filmsbychris.com. That's Chris with a K. I hope that you have a great day. Today, we're going to be looking at encoding messages, and we're going to create a QR code. A QR code, I think most of us know what those are. We see them on products and signs and trucks, and it's just, squares that represent text, basically. And they are very, very useful, can hold a lot of text, and also can be used to give you a bunch of information like URLs, phone numbers, contact information, because all those things are just plain text. And even though a QR code is meant to be read by a computer, they theoretically, if you know how to, the process, you can actually decode them. A human can decode them. It just takes a lot. But they are very, very cool. And in this case, we're going to use QR encode to create them. And you can go online and say QR code generator and find a website. But again, why are you passing all that information to a server somewhere when you could be doing it yourself locally on your machine? So I'm going to use apt. I'm on Debian, so I'm using apt as my package manager. Use whatever your package manager is. Sudo apt install QR encode to install it. I already have it installed, and we are going to, I think I already have it installed. QR. Yeah, I have it installed. We can say QR encode and -H to see some basic options. We can also check out the man page, which will give us more information. Again, with any of the things I'm going over in this series, we can do QR code man. It will give you the full man page, which tend to have more information than the basic help. But this is a pretty simple program, so the help file is very helpful. I have my screen split here. You may be asking why. Because the first thing we're going to do is create an image, right? So I'm going to have a message. I'm going to say, this is my message, right? And so I printed, this is my message. Again, now I can use the pipe character to send that to another program. I'm going to send it to QR encode. Now, if I just say QR encode, it's going to bring up the help because I didn't give it enough information. One of the things we need to tell it is what type of output do we want. And you can see if we do -T here, we can do a PNG, we can do a PNG32, an ESP, an SVG. These are all image types, but then we get into other formats that we're going to talk about in a moment. But let's start off with the most basic. We're going to do a PNG. So we're going to run that same command. I'm going to say -T PNG. Now if I do that now, it says no output name given. I have to give it a name, right, for this particular format. So I'm just going to say it, I'll call it message.png. And a PNG is just an image. And when I do that, I forgot to say -O, to say output. And as you can see in my file manager, we're in the same folder. There's the QR code. This is just a thumbnail of it. It's such a simple message. You could probably point your phone at the screen right now and get that message. Let's go ahead and open it up and zoom in a bit. So right now, if you're watching this video, you should be able to point your phone at it if you're watching it on a desktop. And when you scan it with your phone, it should say, this is my message. That is the text. That is how you create a QR code. But remember, part of this series, we are looking at, we want all our output to be typable text. So that, now, we're going to get into base 64, so I could take that image and make it base 64, which is another type of encoding. So we'll be double encoding it. We'll be encoding it as a QR code, and then we'll be encoding it as base 64, and then whoever gets it would have to decode it into an image and then scan that image. But QR code, again, if we were to just run QR encode -H, or even just give it no option, some of these other options, look, we have ASCII here, and then ASCII, which is ASCII inverted. And then we have UTF-8 and UTF-8I, which means inverted. Let's start off with that, because it looks a little bit nicer, right? So I'm going to run this, and I'm going to say type, and I'm going to say UTF-8. And when I do that, it gives me a QR code right here in the shell. It didn't generate an image. I could dump this into a text file, because this is text. It's Unicode text, which Unicode allows for special characters. So you can see I can highlight this just like I would any other text. So theoretically, I could put this in a text document or send it multiple different ways. They are special characters, so there might be some cases, depending on how you're sending your message, that those might not be able to send. Again, my goal here is not just text characters, which this is, but typable text characters. So again, if we run QR encode -H, we can see here ASCII. What is ASCII? ASCII just means basically, to simplify it, it's a whole standard, but it means you're going to be able to type it on the keyboard. So let's go ahead, run this again, but instead of UTF-8, we're going to say ASCII. Look at that. It's a little bit larger, it takes up a little more space than the blocks, but it's just spaces and it's pound symbols or hashtags, whatever you want to call them. And again, just like the last one, if you're running the video, you should be able to scan that with the phone. If you're watching this on a desktop, you should be able to pick up your phone, point your camera at it, and this should scan and show you the message, this is my message. This is great. I personally like to invert it, so if I just add another I, and this is not case sensitive, I'm pretty sure if I type all this lowercase, it still works. If I do that, it's the same exact thing, it's just flipping what are the spaces and what are the pound symbols. Now, I could take this and I can send this one line at a time in a text. I can send it all in one message. It might mess up the formatting a little bit, but I should be able to send this in like just a standard SMS, non-MMS, a standard text message, one line at a time. And the person on the other end could take all those lines, put them together, and then scan it with their phone. Okay, or scan it right here on their computer. So we've just generated some files. So we have the image we originally created, and then we also have another program, two programs we're going to install. So we're going to say, again, I'm using a Debian-based system, so apt is my package manager. I'm going to apt install zbar-tools, which will give me tools to decode a QR code that's in an image or on the screen, and then zbar-cam will allow me to use my webcam. Just like with your cell phone, you can scan QR codes. This allows you to real-time scan things with your webcam. I'm not going to use that. I just wanted to show you that it was there. We're going to install them, which I already have zbar tools installed. And so now, again, if I list out my files here, I have that original message, that PNG, that image that we created. And what I can do is I can just say Z bar image, and I can give it that file name. And what's it going to do? It's going to tell me that this is a QR code. It's giving me, this is my message, and then it gives me some information. It scanned one barcode because if the image has multiple barcodes, it will decode all of them. It found one barcode in one image in 0.0 seconds, okay? We may not want all that information. So let's look at some other options. If we, again, use the man file, we can look at zbar image, and we have some options here, and we can read about all the details down there. But right away, I see quiet here, okay? So I know that's going to be one of the options I want. So let's go ahead and run this again. We're going to scan that image, but I'm going to say -- quiet. It got rid of this information here, saying what it scanned, how many scanned, and how fast scanned. So that quieted, but we still have this QR code message here. By the way, zbar can also, or zbar image can also scan other types of barcodes, just like UPCs on products or other barcodes. Just so you know, that's why it's telling me here it found a QR code. But I really don't care. I already know it's a QR code, right? So another option, you can go through the man file, but if I just say -- raw, it's going to give me the raw output, just the message, right? So I have this PNG, which is the QR code, and we're saying, okay, let's decode that and just give me the message. So we've looked at, in this video, creating QR codes, both images like a PNG, using Unicode block characters, but also just using ASCII typable characters. And then we also looked at decoding them, right? So I hope you found this useful. There's more in this series to come. Be sure to check out the description of this video for all the notes on everything in this series. And I thank you for watching, and I hope that you have a great day. Today we are going to talk about base 64. Base 64 is a great standard for encoding. Again, this is encoding, not encrypting, because anybody who sees base 64 can decode it. There's no password, they can just decode it, but it's very, very useful. And basically what it comes down to is you can give it any information and it will convert it, encode it, as typable characters on a keyboard. This is great if you can only send messages as text. You can encode, again, any binary files, so like images, JPEGs, PNGs, videos, MP4s, AVIs, MOVs. You can encode PDFs, Word documents, MP3s, anything. Also, just regular text. And your file size might go up a little bit with certain things like images and video files because those are already compressed and now you're encoding it, so it gets a little bit larger. But it allows you to, again, have things as plain text. And this is something you interact with all the time, but you may not realize it. We all do email, right? In email, if you ever got an attachment that wasn't just a text file, it is going to be base 64 encoded, right? If you were to go to whatever you use for your email, Outlook or Gmail or Mutt, you can look at, there's an option somewhere, different in different programs, to look at the raw data of that text, which give you all the header information on what servers it bounced off and all that stuff. But the attachments, you will say, this is attachment, it's this type of file, and then it will give you a whole bunch of what may look like gobbledygook to a lot of people, but it's base 64 characters. It's typable characters. And one of the things you'll see, I don't know exactly how the standard works, but lots of times the messages end with a equal sign. So that's right away when I say, I go, oh, it's base 64. It's also very useful. Again, anytime you need to send plain text, but in a web browser, right? I can link images. So if I have a web page with images on it, usually you're going to link to an external image, but I can embed an image right in the web page using base 64 to encode, or really any type of file. And I don't need more than one file. So if you just wanted to have a document that was an HTML that didn't reach out to anything external, you could encode all your files as base 64 and put them in it. Let's just get into it. I've talked enough. So base 64 is going to be installed on all your Linux machines by default, okay? So again, we're going to use the example of this is my message, so that prints out the message. I'm going to pipe that into base 64, and there is a base 32, and I think there might be a base 128. Base 64 seems to be what's used most places. We're going to run that, and again, see how it ends in equal? That is a sign that this is base 64. Even if it's like 5 pages of text, it will end in equal. I've seen sometimes where it's not. I'm not really sure why or not, but that's just a sign. If you see something looks like a whole bunch of just random letters and it ends with equal equal, go, oh, that's base 64. So how do we decode that? Well, you just take that message, you say echo, so I can echo. Again, that would just show that information. But I'm going to put it back into base 64, and this time I'm going to say -D for decode, not decrypt, because again, this is not encryption, this is encoding. And now it says this is my message. In the last video, we talked about QR codes. If I list out my files here, I still have the QR code in here. So this is a PNG file, right? If I was to try to display what's in that file as if it was text, it would look like this, right? That's binary information. We have some, looks like typable stuff here, but some weird characters. And a lot of this looks like empty space, but it's actually a bunch of different stuff. You can look at it in hex editor, but it's not plain text. You can't just send that as a text message, right? It would lose stuff and you wouldn't be able to decode it. But I could just say base 64 and give it that file. And look, this is that image. It didn't end in the equal equal. Like I said, it doesn't always do that. This is a common thing. Maybe someone can elaborate on that in the comments. But I can send this to somebody as a text message or any type of text message, like an SMS message or an email or however you want. Any way you can type text out, you can send this, and then they can take this and they can decode it. Now, another option, this breaks it up line by line, which would be nice, like because text messages are limited in size, right? I could break it up and send each message individually. As long as the person keeps them in order, they can put them back together and decode them. But you could also say -W to give a line width, and if you say 0, it puts it all on one line. So this is going to be the same exact thing. Again, this is encoding, so it's going to give the same exact information every single time for the same thing. So as long as I'm passing it the same message or the same file, the output's going to be the same. This is just getting rid of the line breaks. Okay? So yeah, that's base 64 in a nutshell. And again, it's just encoding, not encrypting, but you could encrypt something. Well, like we talked about in our first video with OpenSSL, it has an option where it makes it base 64 for you already, but you could encode anything. So even if you had an encrypted file that wasn't already base 64, you could base 64 encode it, and then someone could decode that and then decrypt it. And you could have these layers of messages in there. As long as someone knows the proper order and any passwords that are required, they could get your message. So yeah, that's base 64. Again, super useful. If you can type a message to somebody, you can send them any type of information. Obviously very slow. Like, right, I said you can encode an MP4, like a movie like this, but an MP4 already, like let's say you had a full movie that was really compressed. Let's say and you get a full movie at a gig in size. When you base 64 encode it, it's going to end up being bigger than a gig. And to type out a gig worth of information is not going to happen. But be aware that you could do that theoretically. So thanks for watching. I hope you continue watching this series, and I hope that you have a great day. Hello and welcome. Today we're going to be talking about steganography. What is steganography? Well, steganography is the art of hiding messages. Okay, so we have encryption, which encrypts it, and you need a password to decrypt, and then you have encryption, encoding something, which basically just puts it in a different format that you can later decode. It's almost like putting it in a different language. But steganography, again, is hiding a message. So think about it like this. It is like, okay, let's say you have a safe in your house where you keep your valuables. Someone breaks in. If they know how to break into the safe, they're going to go to the safe and break into the safe. But if you put the safe in the wall, well, they may not know if it's behind a picture. So they need to, one, know that you have a safe and know that you're hiding it. And then they need to find it, even if they know you're hiding it. So it's kind of the same thing. We can take messages and we can put them in other files. So what we're actually going to do today, we're going to use a tool. So originally, I was going to start off, and I'll do this in a future video, I was going to talk about a program called Steghide. So if I did sudo aptitude search steg, it will bring up any program that has the word steg in it. And there's a few here. Steghide, I've talked about this years ago. It allows you to hide messages in images, and I think it also allows you to hide messages in MP3s and other file formats. So we were going to do that, which is great, because you send someone a picture of anything, and they think, oh, it's a picture. And it's not like they're hiding the text in the image. No, it's embedded in the file, and you need a tool to get it out, which would be Steghide as well. But when I was about to install this, for recording this video, I saw this Stegsnow, which is steganography using ASCII files, which again, one of the points of the series is anything that we do that we encrypt or encode, we want to have it in ASCII, which is typable characters, right? So I installed it, and it is a pretty cool program. So sudo apt install Stegsnow on a Debian-based system or on any other Linux system. Just use whatever your package manager is. Let's go ahead and look at Stegsnow, the man page. So again, the man page is the manual page. And right here, it gives you basic things. It tells you, you can enter a password, you can give it a file or a message, and then you have input and output files. But what is Stegsnow? A description. Stegsnow, and I'm assuming I'm pronouncing that right, is a program for concealing messages in a text file by appending tabs and spaces on the ends of lines and for extracting that information. Also, if we scroll down, this is not just security through obscurity, which I don't think security through obscurity is a bad thing as long as you have other things in place. So security through obscurity is like basically hiding stuff in plain sight. So just hiding the message, that's good, not by itself, but it's good. Again, it's like having stuff in a safe. You could hide stuff behind a picture frame, but it'd be better to hide it behind the picture frame in a safe. So first they have to find it, and then they have to break in. This is the same thing. It does do encryption upon the messages. See right here, encryption is also provided using ICE encryption. So the messages here are going to be hidden and encrypted. That's why we give it a password. So let's go ahead and start using it. So let me look in my directory here. I have 3 files. I have an image that we created, but then I also have this message file and another text file. Let's look at what's inside this message file. Boom. It's just a couple of lines of text that I created. So what we want to do is I want to pass a message, my hidden message, to Stegsnow and hide it in this text. And it's going to do that by appending tabs and spaces to end of lines. So let's see what that looks like. So what I'm going to do is I'm just going to copy and paste the command here. So I'm going to say Stegsnow -c-m. M is my message. We got this. This is a capital C, by the way. We're going to say this is my hidden message, and then -p and give it our password, and then we're going to give it our input text, which is our message.txt, and then I'm going to create a file called hidden_msg.txt. I do that, and it tells me here, it gives me some output information, blah, blah, blah. It says 1 extra line was created. Let's go ahead and look at that. I'll use gedit for, well, first let's cat out the file, right? So I can cat out my hidden message.txt, right? It looks just like before. There is an extra line at the bottom, and it did tell me in the output when I created this, where was it? Right here, an extra line was added, and that's just because this text file is so small, there wasn't a whole lot of room to hide stuff, so it had to add an extra line. We'll talk more about that in another example in a minute. But look, it looks the same, right? So let's go. This is our original text file. This is our new text file. You don't see the difference other than that extra line at the end, which won't always be there if it was a bigger file. Let's go ahead and use another program. I'll use gedit to open it up, right? Gedit's just a text editor, like Notepad or whatever. Again, there's the message, the original file. There is an empty line here. Again, if it wasn't numbering, you may not even notice it there. If I go to the end of each line, though, you can see there's like spaces here. It doesn't just end at the word, and that's where all our messages are hidden. So most people would not know that. If you didn't know that someone was hiding a message, you wouldn't know to look at that. Little obvious, little obvious in a small file like this. Again, let me go use another text editor. I'll use Vi. I'll open it up. By default, you don't see anything. Let me use my NeoVim, right? NeoVim, I have particular things set up. It's for programming and stuff. So, not NeoVim, well, NeoVim, but NVim. I have it set up so I can see white spaces. So I actually do see a little bit in my text editor. But most text editors, you wouldn't see anything. And even if it did, you're just like, oh, there's extra spaces. I actually have a key on my keyboard that removes all trailing spaces and white space and whatnot. But most people would not think anything of that. And even if they did, it's still encrypted. They would need to know your password. Yeah, I used the password, which isn't very good. But now, how do we get it out? Well, I am going to give it this command. Stegsnow -C-P, password, and then our text file. And what it's going to do is just going to output our original message, right? So definitely my message, the message I'm sending here is small, and the file I'm hiding it in is small. So it makes it a little more obvious. Well, I also have in here, again, another file called oz.txt, which, if I was to cat out, is the entire Wizard of Oz textbook or novel. If I was to count it out, there's 2,296 lines, 39,627 words, and 212,409 characters in there. So hiding my message in there, no one would notice it whatsoever. So let's go ahead and do our command from earlier. So I'm going to pass it the same hidden message. Again, it could be a whole file, a whole text file. Again, looking at the man page, you can pass it an input and output file. Right here, I am just giving it a message in my line, and I'm giving it this password. And instead of hiding in here, I'm going to say look at the Oz file, and then we'll say instead of hidden MSG, we'll say hidden Oz. There we go. No, extra line at the end because it didn't need it. If we were to open up this file, again, I'll say gedit as an example, and I called it hidden Oz. It's like going through here, you are not going to find that message. And so I could, in a big text file like this, I could hide a pretty big message and no one would notice, again, unless someone knows to look in there. And even if they did figure out that you were hiding a message, they would still need to decrypt it. And I mean, one of the best ways to do that, again, when we did our sudo, I guess I don't need to sudo, I'll just aptitude search steg. There are tools that will try to crack these things. I haven't tried it right here, but it's a brute force tool, right? Brute force means it's going to go through and try all these different passwords. So as long as you use a pretty decent password, it's going to be hard to crack. Brute force is, if it's a long, especially if you add special characters, but a long password is going to take forever for someone to brute force. There's another tool here that says it's the world's fastest StegHide cracker. I don't know exactly what it's doing, but again, cracking and brute forcing is possible once they got a hold of the file, got it on their own system. If they have a powerful machine, they know that the hidden message is there, and somehow they're going to, I don't know what the cracker is doing, right? This one obviously is brute forcing, means it's just trying every possible password. Cracking could be done in different ways. Use a secure password, but again, just don't let people know you're hiding a message in there. And again, you can also then encode things different ways and encrypt. You can encrypt the text file, so someone will decrypt it and go, oh, it's just the Wizard of Oz, and they might stop there. You could do layers of techniques like that. So anyway, this was Stegsnow. Again, in a future video, I'll look at StegHide, which does the same thing but hides it in an MP3 or an image file, which is going to do an even better job of hiding it because no one's going to open up an MP3 in a text file and go, hey, there's some other information here. It's just unless they know you're doing it, they're not looking for it. So that's the point of steganography. Have a great day. Hello and welcome. Today we're going to be looking at a program called Minimodem. I may have talked about this in the past. I know I've talked about other forms of communicating text through sound. So you can do this over radio waves or across the room. If you have a microphone and speaker, you can send messages. There's lots of different formats out there. Some better than what we're going to do today in certain ways. I like Minimodem because it's simple and it can be done in the shell without any GUI interfaces. But other options would be like something like PSK31 and FSK something or other. So what Minimodem is, and again, if you're on a Debian-based system, it's going to be in your repositories, sudo apt install Minimodem. Once you have that installed, which I already do, you can then use it. You can pass it text, and what it's going to do is it's going to encode it as audio. This is, if you're old like me, you remember the dial-up modem days. This is exactly what this is, although we're just going a one-way communication here. But I can take a message like this, echo, this is my message, and it gives me that message. Well, I can take that and I can pipe it. Again, using the pipe character means put it into another program. So I'm going to take that message, I'm going to put it into Minimodem. I'm going to say --tx for transmit and --ASCII. Again, ASCII basically to just simplify as much as possible, typable characters. We can type it on the keyboard, it's ASCII, okay? And then we have our rate. The higher this number, the faster the message will be sent, but more likely for you to get errors. I'm going to do 110 here, but you can try experiment different things. Now, you may be able to decode this message depending on the quality. I'm not recording the audio directly through my system. It's going to come out my speakers and go into my microphone. I don't know how well you'll hear it, but it's going to sound like an old dial-up modem because that's basically what it is. So theoretically, if you had Minimodem running on your machine listening to that audio, you would have gotten the message, this is my message. Let's hear it again. right? Not very long for a short little message like that. So if you wanted to decode it, what you would do is basically the same thing. You would run minimodem -rx ASCII 110. So I'm not going to play it out of my audio and back in. We're going to actually decode something here because this has been used before. This is something that's been around for a long, long time. And some of you might be familiar with a band from the 80s called the Information Society. Well, the Information Society, back in the 80s, on one of their albums, actually had a whole track that was just a message encoded like this. Again, this is encoding, not encrypting, one of the topics of this series. So if you knew what you're doing, you could decode their message. Well, that song is up on YouTube, and if I list out here, I have an audio wave file here. I can now pass this. Let me play it for you. So I'll just say MPV. I'll skip ahead a little bit. So it's 3 minutes long. Now I could play that whole audio file, and if you had minimodem running on your machine with a microphone going, you could get the message. Again, depending on the quality of it, you could lose characters theoretically if the audio wasn't very clear. But the rate of this song, or this message, is 300. So all I'm going to do is I can pass that file directly to minimodem. I don't have to go through my microphone. So I'm saying minimodem -a-f for file. I'm going to give it that file, and I'm going to say, just from information I found online, that it's at a rate of 300, right? So now I hit enter, and it doesn't even have to listen to the whole thing real time. It can do it faster when it's actually looking at the file that way. But it's a whole message from the band to their fans if they were able to decode it, again, 40 years ago, right? Or 35 years ago. So, very great way. You could, again, send this through radio waves across the room with a speaker, or you could give somebody an audio file. Also, I have, if you look back, way back, probably 13 or 14 years ago, I uploaded a music album that I made to my YouTube channel. I actually have a whole separate channel for music now, but on this channel, I have some music, and the first track, I had like the music going, but in the background, I had something similar. It was PSK format, but I had a hidden message there. So you could also be careful because you might lose some of the message, but you could mix this with other audio. You could put it in the background of other audio in a file. Again, so lots of different things you could do with this. We're taking plain text and we're making audio out of it, and we can send that file or the audio over radio waves or across the room to a microphone, different ways. So again, this is encoding. People who are aware of it are going to know what it is. It's not encrypted. You could, again, encrypt a message and encrypt it and then use base64 to create plain text. And then you can send that message across the airways or in an audio file like this. And then the person can decode it, then decrypt it. Again, we have layers of things, but we can send messages different ways. And again, the trick to all of this is eventually getting to that plain text of the base64. So anyway, just a thought. Since we're talking about messages and sending messages, I thought I'd throw minimodem out there. Again, it's not the only option. There's newer options that ham radio is to use. Again, if you are doing this over radio waves, there are laws about what you can and can't do. Look into those. But yeah, thanks for watching. Filmsbychris.com. Have a great day. Today we're going to be looking at Morse code. And I got to be careful how I say that. You know, I'm 43 now, almost 44. And just a few months ago, my wife informed me I was saying that wrong. I kept putting an extra vowel in there. I kept on saying Morse code, but it's Morse code, not Morse code. So if I mispronounce during this video, you have to forgive me. I am trying to get over a 40 years of saying it wrong. But Morse code, we're going to Morse code stuff. We're both audio and visually, right? Dots and dashes. So we're going to install two programs, sudo apt install Morse and Morse to ASCII. And again, what is ASCII? It's a standard for characters. Again, to simplify it for these videos, we're just saying if you can type it on the keyboard, it's ASCII, okay? And which is what we're going for now. Now that I have those two installed, I can use the program Morse. So again, just like all our previous videos in this series, I'm going to say echo, this is my message, I'm going to pipe it to Morse. What does it do? And And there we go. It created some Morse code audio for us. Did I just say Morse code? Morse code. Anyway, so again, that's how you create it. Now, I've recorded this exact message into an audio file, a WAV file. So now we're going to use the other program we installed called Morse to ASCII to convert it back. So all I have to do is say Morse to ASCII and the name of the file that I've saved the audio to, and it gives me this output. It gives me information about the audio file, but then down at the bottom, this is my message, right? So it got it. Also, I'm pretty sure Morse code is not case sensitive. Like it only has one case, so it's going to all be uppercase or lowercase. So we do lose the case sensitiveness of this, which is important if you're trying to send something like I've talked a lot about. Base 64 does have uppercase and lowercase characters by default. That would mess up the encoding if we did everything lowercase or uppercase. So we do have more information here than we need. Let's quickly look at Morse to ASCII and see if there's a quiet option. Q codes parsing. I do know how to. Okay, it doesn't say anything about that. I see real quick. So if we don't want all this extra output and all we want is our message, the message is standard output. Well, the other information here is not. So what we're going to do is we're going to take that and we're going to say two pipes are greater than symbol. We're just going to redirect that into a null file. So dev null, that means just basically dump it to garbage. So the only thing that's left is our standard output, which is our message right there. So again, we had our message here, which is, this is my message, again, with a capital T. I saved that to a WAV file, so it's the same message, and let it finish. But when we do it, we lose that case sensitiveness. Before I forget, I also want to remind you, all these videos, there's a link in the description to all of the notes on this, so you can copy and paste stuff for yourself. But let's go ahead and sudo apt install MorseGen, which is another application. Looks like I already have it installed. Great. I actually recently used this in a video. So MorseGen, you can give it a file, but I'm going to go ahead and echo into it. I'm going to say, again, this is my message. This is going to give us Morse code, but in dots and dashes, visually using dashes and periods. So there you have something that you could actually send to somebody as plain text, in a text message or something like that with dots and dashes. And all they would need to do is know Morse code, or, just be able to look it up. Again, if we use a man page and look at that first program, Morse, and we go through here, there's lots of options. You can speed it up. Looks like there's volume options, frequencies, lots of different stuff. But there's also a chart here of how things are encoded. So, right there, you have on your system different ways to encode different things. If you want to just look it up for reference stuff. Also, look at my previous videos. I use this MorseGen to create these dots and dashes and then convert those to timestamps to make the LED on my keyboard flash. I don't know if all of you saw that video. Maybe like a year ago I did it. Yeah, check my channel out for that. And so you could send people messages by making different LEDs on their computer or keyboard flash using this, if they know Morse code and you know how to make those LEDs flash. So check that video out. Thanks for watching, and keep on watching. I hope that you have a great day. Hello and welcome to this video from filmsbychris.com. That's Chris with the K. Be sure to check out the links in the description of this video. There you can find all the notes for what we're going over today, as well as the other videos in this series. And there's also links to my website, where you can search through my videos and ways to support me if you like my videos. Let's go ahead and let's create some barcodes. In the previous video, we created QR codes. QR codes are awesome, way better than standard 1D barcodes that we're talking about today. I also want to point out that UPCs on products, when you go to the store, grocery store, or wherever, their UPCs are a barcode, but not all barcodes are UPCs. UPC is a particular format of barcode, which you could generate as well, but just following that standard. But I'm gonna have this message here, echo, this is my message. And well, first off, you have to make sure that barcode is installed. So sudo apt install barcode is the command on a Debian-based system. I already have it installed. There we go, so it's good. So let's go ahead and take our echo message. I'm going to say, echo, this is my message, and we're just going to put that into barcode, and let's see what happens. Oh, we got this information on the screen. What is all this? So what it's doing is it's generating what's called a PostScript file, a PS file, which is, just to simplify it, there are differences, but it's basically like a PDF, okay? But it gave me the information. That's what it looks like. That file actually looks like. It's that information. Let's bring up my file manager. So I'm in the shell up here on the top. This is the same folder I'm in down here. Let's go ahead and delete that. So now what I'm going to do is I'm going to run that same command. I'm going to give the message barcode, but I'm just going to redirect it. So greater than symbol, and I'm going to create a file called message.ps. Now you can see we have a PS file here. To check that we did everything properly from the shell, file, you give it a file name and it will tell you what type of file it is. And it should tell me this is a PostScript file. It does. That means that it converted properly or generated properly. Let me go ahead and click on this. It's going to open it up just like again, like a PDF basically. Let's go ahead and open this up. And this is how it formats by default. It gives you a full page and puts the barcode at the bottom. I don't know why it's like that. I've looked through the man page. I don't see a way to change that with the strict output. But what I'm going to do is I'm going to use ImageMagick. What is ImageMagick? ImageMagick is a suite of tools. Think of it as like Photoshop for the shell. If you can edit and manipulate images certain ways in Photoshop, you can do the same things in the shell using ImageMagick. Good chance it's already installed on your Linux machine. If not, just sudo apt install ImageMagick. One of the tools is their convert command. So let me go ahead and run the same command before. Instead of dumping it into a file, I'm going to pipe it into convert, okay? So convert, I could just say convert MSG JPEG, and that would create a image, a JPEG image, exactly like that PS file, right? It's just going to be an image. But here I'm saying, okay, take the standard input, that's what we're converting, trim it, and repage it. That means if there's any white borders, remove all the white borders. So if we do that, we now have this MSG file. I can double click on this and open it up in my file viewer. Let's try it again. Open up Shotwell. There we go. So we have this. It tells you what the message is under there, but I could trim this off. Like if I wanted to crop it and just be the dashed lines, you could read it with a barcode scanner. Most cell phones will read it. So you could have a message this way. To have a decent message, a decent sized message, the barcode's going to get pretty big. That's where QR codes come in. They compress things very well. A teeny tiny QR code can hold a couple of pages of text, basically, where a standard barcode like this cannot. But if you needed to, you could do this. And the nice thing about this, it's just, lines. I could trim this down to like 1 pixel, and it could be read by something that reads barcodes. So, for example, in a previous video, we talked about Z-bar image, and then again we're going to give it the quiet and the raw, quiet, raw, so we don't get any of the extra output, and then I'll give it my message.jpg, and it tells me what the message is. So theoretically, I could send somebody a bunch of barcodes, and they can decode a whole bunch of them and get a message. Like I could literally just send a 1 pixel high image to somebody, but a bunch of them, and then they could decode them in order and decode a whole book's worth of stuff. So even though the barcode could get big, I could have, again, each barcode be just 1 or 2 pixels high, stack them all together, and with using ImageMagick, trim each one, then decode them. And actually, I don't even know if I would need to decode them, because if I put more than one barcode, okay, let's experiment. I'm gonna play around, and so now I'm going to just try something I haven't tried yet. So I'm going to say, hello world. So I'm creating a message 2. So now we have message 1, the first message here, and message 2. I could trim them down, but let me just go ahead and put them together. So I'm going to say convert, and I'm going to say message 2. Actually, let's do message 1 first. The message JPEG, message 2. I think that's all I have to do. And then for the output, I just say new.jpg. There we go. It is right here. I need to change my default viewer. Actually, no, that's not the command. Let's do this. We're going to do the same thing. We're going to take those 2 images, and I have to say dash append. And I could actually just say all those. So if I had a whole bunch of messages starting off with MSG, that would work right there. Let's do that. Now they're stacked. Now if I look at Z-bar image dash quiet raw, and I give it the new message.jpg. Nope, it only got the one barcode. I thought maybe it would look for multiple barcodes in that image, but it just found the last one, I guess. So might need to do a little bit of work, but theoretically, again, you could stack a bunch of barcodes to get larger messages. I'm just theorizing now. That's the whole point of this series. It's just fun ways to think of how you can communicate messages different ways by encoding them different ways. So anyway, that's a look at barcodes. I hope you enjoyed this video, and I hope that you have a great day.